This episode of Fluid Power Forum is sponsored by IFPE Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFPE spans the 13 central states from Minnesota to Texas. For more information, visit ifpeusa.com.
It's not one size fits all, obviously, but, it's just an innovative system architecture with the simple components that could be applied in many, many places.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, follow us on Twitter. You can find us there at the NFPA. And while you're there, you can share interesting and innovative uses of fluid power with our hashtag, #OnlyFluidPowerCan. That is, in fact, one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag, #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts. We're on Spotify. We're on a lot of the other podcatching services. Wherever you find us, go ahead and subscribe and then give us a quick rating. That really does help more and more of our friends in the industry join in on these important conversations. On today's show, our guest is Barun Acharya. Barun is an electrification systems application engineering manager for Parker Hannifin, a diversified manufacturer of motion and control technologies and systems that provides precision engineered solutions for a wide variety of commercial, mobile, industrial, and aerospace markets. Parker Hannifin will be exhibiting several hydraulic-electric hybrid systems for implement control in mobile applications at IFPE, the International Fluid Power Exposition. And so we invited Barun into our forum today to learn more about those applications and the fluid power systems that make them possible. Barun, welcome to Fluid Power Forum.
Thank you very much, Eric. Thanks for inviting me on your podcast.
Yeah, we're glad to have you on the show. We have an exciting topic to go over today, something that's really changing the landscape of the market right now. Before we get into some of those details, I'm hoping you can tell our listeners a little bit more about yourself. How did you find yourself working at Parker Hannifin?
Sure. My name is Barun Acharya, and I am the System Application Engineering Manager on Electrification for the Motion Systems Group at Parker Hannifin. And basically, I've worked on manufacturing and design roles in the hydraulics industry most of my career. With Parker, I've been for about 20 years. I started in hydraulic component design, where I was designing low-speed, high-torque roller motors, and then designed some hydrostatic pumps, and then integrated hydrostatic transmissions, or what we call the IHTs. Mm-hmm. These are specifically for the turf market. I don't know if you've seen the design is basically a pump, a motor with the brakes, shifts, charge pump, reservoir, filter, everything kind of integrated together. So really proud of the work we did. Mm-hmm. And then I kind of changed my career. I moved to Elk Grove Village, Chicago suburbs, which is the systems design and development center for Parker. And that's where I've been for the past 8 or 10 years. And out of those last 5 years, seems like most of my projects have been on electrification. Yeah. And lately, Parker, because of the interest from our customers on electrification, and they formed this electrification growth team. And I'm leading the system application engineers for that team within Parker.
Yeah. It sounds like you have a great foundation in hydraulics to get into what is, as I said, one of the, I hate to use the word hottest trends in the industry right now. But that whole electrification landscape is really changing how we apply hydraulic technology on a lot of these machines.
It absolutely is. Yeah. I think it is giving this new vigor to this mature field of hydraulics.
Yeah.
So this is a dream come true for all systems engineers.
You only mentioned Parker in your little history there. So have you worked at Parker your whole career, or have you had other positions?
No, before Parker, I used to work for Eaton Corporation, part of their hydraulics group at Eden Prairie. So actually, I started before in manufacturing, and I think within a year, I found out that was not challenging enough for me. So I really wanted to go into the design aspect of the component side, if you would. So then I moved to Eden Prairie, and then worked on many projects there. And then from there, I moved to Parker for the past 20 years.
So when did you first encounter fluid power? Was that part of your academic career or not?
Yeah, that's a good question. I came to U.S. From India and I studied at Oklahoma State University, which happened to have some of the top professors in hydraulics. But to be honest, I didn't take a single class in hydraulics because I thought it was like a kind of a dead area. So, but it just so happened, I had an interesting job offer.
Right.
And then the more you get into it, it's kind of hard to leave hydraulics. So, and that's really what I've done all my career since.
That's great.
Then.
Yeah, they call it the hidden giant for a reason. It's unfortunately not so well known, but once you discover it, it digs its claws into you. It's an exciting technology, and it sounds like you're doing some innovative things with it.
Yes, absolutely.
So
thank you.
Yeah, and so you're now at Parker, as you said. You're leading the electrification task force. Is that what you called it, or the study group?
I think it's the official title is the Electrification Growth Team, but which is called the Electrification Team.
So I'm sure lots of people have heard of Parker Hannifin, and I gave it a little bit of an overview in the introduction there. But tell us more about Parker as a company. What kind of markets do you sell? What products do you make? What kind of markets do you sell into?
Sure. Parker Hannifin is a Fortune 250 company, I believe. And we are number one, or the global leader in motion and control technologies and solutions. Revenues are around $16 billion with the $40 billion market cap. But we basically have unmatched breadth of core technologies, including hydraulics, electromechanical, filtration, pneumatics, engineering materials. So there's this core technologies within Parker. And I think one of the other key differentiator within Parker is the over 17,000 distribution outlets that Parker has, and it actually generates about 50% of our revenue. And in terms of markets, Parker, we have a vast array of customers, from the medical field to some of the industrial. So I'm not going to talk about that. I'm going to talk about a market that our team focuses on, and that's on the mobile markets.
Right.
And primary focus is on ag, construction, forestry, material handling, refuse, mining, truck and bus, turf care, and defense.
Right. That's a wide spectrum, but there's probably some commonalities, I would imagine, to the environments that a lot of those machines operate in. And maybe that's a good segue into, getting into the meat of our discussion. So we've tossed out this word electrification a few times now. Maybe it's worth talking a little bit about what that is and why it's happening. What's going on in the market, Barun, right now that's really driving things in this direction?
I think it all starts really with the electrification of the automobiles. So these are the light vehicles, the projection is we're going to have 25 million, year over year car production by the year of 2028. So, it's a mind-boggling number. I think Tesla made like 140K units this year.
Right.
So I think that's kind of setting the trend. And then the other trend that we are seeing, which is this clear adoption of this electric, so it's not a fad anymore. So we're past that phase. And we are clearly seeing this migration from this lighter vehicles to this heavier machines. So starting with the trucks, buses, and then into the off-highway market as well.
Right.
And then in terms of the drivers, I think it's like a carrot and stick, so the government incentives coupled with the regulations. So I think that's one of the key drivers. For example, in California, you have the HVIP, the Incentive Voucher Project.
Right.
And then you also have the Air Resources Board that's coming up with these regulations where they're not going to allow, or they're going to allow zero emissions only in certain areas. And I think the other piece, which is probably even more important, is the corporate ESG initiatives. And this is where the top companies within and globally, frankly, are saying that we are going to exert this adoption of electrification or reduction of or the CO2,
right,
curbing the CO2 emissions, if you would. So I think these two are the main drivers that's really leading the electrification market.
Yeah, it really is. That the emissions profile is one of the key drivers, as you just described, and the need to reduce that either for corporate sustainability reasons or for government regulation reasons, or even for market demand. I think that's the piece that we're beginning to see more and more, is that the market's actually demanding this more so than being forced into it. Is that what your sense of it as well?
Yes. Yeah. I mean, we see more and more interest. All the customers, and the other thing we're seeing, the customers, they don't want to be behind. So we have so many projects, more than what we can handle. And I think the big thing is the adoption rate, so which market is going to take the lead and, is going to get us this big revenue on the electrification. I think that's the piece we're waiting on. So it's kind of exciting times, but also kind of on hold in terms of, when this, the hockey stick curve is going to ramp up.
Sure. Right. And if the goal is, emissions reduction, then that is why people are looking at those internal combustion engines and moving them off and moving some electric power source onto in this case, the off-highway vehicle, right? That's, as you said earlier, that's really reaching penetration on the on-highway market currently, but just now beginning to move more aggressively into that off-highway space.
Yes, absolutely. Because I think what they have seen is with the regulations and they have already done all they can on the automobiles,
right,
or on highway. So now the big piece, when they study the CO2 emissions, so the big drivers are now the off-road. So this is where the focus is.
Right.
And I think what we're going to see in the next 8 to 10 years is going to be the steady decline of ICE engines, like you're saying, and then they're going to be replaced by electric battery, fuel cell.
Right.
So there's going to be different other players which are going to take over. But this transition is going to happen in the next 8 to 10 years, and they have major implications for the whole machine.
Right. Well, and one of those implications, it's sometimes people ask, if you're electrifying the propulsion system, for lack of a better way of saying it, why not electrify the whole vehicle? Why not do electric actuation for the implement function as well? And there's real reasons why that's not happening, at least not in the same spaces at the same level. Hydraulics continues to play the dominant role in those the implement functions on these machines. Can you speak to why that is? Why is and what challenges that brings up? When you try to marry that to an electric power source rather than an ICE.
Yeah. So if the customers really want to get some work done, right? So they don't care how that happens. So imagine if you could make a electromechanical actuator that's going to do the job that the hydraulics does. I mean, the customers are going to go in that direction.
Mm-hmm.
But the problem is hydraulics, with its power density for obvious reasons that everybody knows. Plus, it's a mature market with the robustness, the reliability of hydraulics at the price point where it stands. I think it's very hard to beat that, and then replace that with electromechanical actuation. Of course, it's going to happen in certain niche applications, certain niche functions where it makes sense. because of maybe efficiency reasons and other reasons where you could recover some of the energy rather than changing from, say, electric to hydraulic to mechanical. Why not just go electric to mechanical,
Mm-hmm.
So there it kind of makes sense, but in many cases, it does not make sense for the off-road work function type application.
So I know that your group and Parker more generally is developing hybrid systems for a lot of these machines. Hybrid meaning, again, hydraulics married to electric power sources to continue to do the implement functions. There are two that I understand that we're going to talk about in more detail. One is for a backhoe loader, and the other is for something called a side loader. I think that's a waste vehicle, if I remember correctly. So we're going to want to get into those details. But before we go there, Barun, we've reached the point where we have to take just a brief pause because I want to tell our listeners more about IFPE, the International Fluid Power Exposition. IFPE is the place where you'll learn everything you need to help your company stay at the forefront of megatrends affecting your business and industry. From sensor technology to data analytics to robotics and automation, you will see the latest innovations in fluid power that will help your machines and applications achieve your technology, performance, and business goals. Only at IFPE can you have in-depth technical conversations with other engineers and other executives to spark new ideas. Or you can talk to your suppliers about your specific challenges and see the solutions that they offer. Or you can find new suppliers and new ways of doing things. Or attend innovative education classes and sessions that cover the latest fluid power topics and industry trends. IFPE is a trade show, and no other trade show brings together as many sectors of the fluid power, power transmission, and motion control industries together in one place. And this event happens only once every 3 years, in conjunction with ConExpo ConAg, the largest international gathering for the construction industries. Our next IFPE show will be held March 14 through 18, 2023 in Las Vegas, Nevada. To learn more about the show and to reserve your place, visit IFPE.com. All right, Barun. So like I was saying before the break, I know Parker's been working on a lot of hybrid solutions. I think there are two that we want to talk specifically about and talk about the changes that are coming. Well, let's start with that backhoe loader. Can you talk about the specific design solution you guys came up with for that?
So the backhoe loader, it's a technology demonstrator. So like you mentioned, Parker believes there's a place for a fully electric vehicle as well as for hybrid. We think for heavier machine where payload is important, like a refuse truck or a piece of construction equipment, say greater than 75 horsepower, when the battery cost hasn't come down as much as it's projected to. In those cases, the hybrid makes a compelling solution. Mm-hmm. And when you study the total cost of ownership standpoint, that makes sense. So in our case, what we did is on the electric hybrid project, we downsized the engine from 75 horsepower to 50 horsepower. And that way we could cut down the cost of the engine quite a bit. And the system architecture was very simple. We use all off-the-shelf components. So basically we had this downsized engine with a PTO clutch and then a piston pump. I'll tell you the reasons. We used a variable piston pump with the electric displacement control with a through drive. And then on the back of it, we had a motor/generator, which was controlled with an inverter and a small battery pack. Mm-hmm. So the idea was to cut down the size of the battery. So in this case, we cut down the battery to a 10 kilowatt hour battery pack. And we could, other key thing with this backhoe is we could also run it we could imagine the PTO clutch. I could disengage the clutch, and I can also run this backhoe when it's in the backhoe mode in a fully electric mode only. So the IC engine is completely off, and you could also run it engine only mode. Imagine your batteries are completely gone for whatever reason, or you had an issue. So you could just engage the clutch and just like a normal machine, but of course lower power because you have a smaller engine.
Right.
And then, of course, the main target is to run it in the hybrid mode. This is where the electric motor is working as a motor or a generator, depending on the amount of work that the engine is doing. So if the engine is underloaded, then we turn the motor into a generator and we start charging the batteries. And when there is an overload condition or higher than what the design point is, then the electric motor turns into into a motor and starts assisting the engine.
Wow. That sounds complicated in terms of all the different system connections, but it sounds also like it offers a lot of versatility, and obviously the objective there is to maximize the efficiency of the system using the right power source at the right time, it sounds like.
Absolutely. I think all the components are standard. You're right. The system control is complex because you have to manage all these operating modes. And then, the seamless transition between the modes, because you don't want the operator to know when the motor is acting as a motor versus a generator. But really, those are just software. So I mean, it's a very easy to do once you have developed the controls. There's a lot of things you can do, like adaptive controls. Depending on if there's an aggressive driver, somebody's abusing the machine.
Right.
You could, make changes, or you could. We offered them like a productivity mode or like a boost mode. So if somebody wants to get the job done quickly, or a eco mode, if fuel efficiency is the objective, they could do that. So there's different ways, different possibilities, imagination you could do on the control side.
So just to be clear on that, it sounds like, despite the complexity of the system design and the control algorithms, it's a very simple vehicle to operate. It sounds like the operator doesn't need to make those decisions. The machine is smart enough to know what pathway to choose, I guess, right, for each task that it's performing.
Absolutely. So all the software. So we have the customer interface as simple as possible. So you could select whether you want to, so if you are in a bad shape because something bad happened, then the system, you could just select engine only mode, or the system will select automatically.
Right.
So that's feasible as well.
And you described this as a technology demonstration effort, so
yes.
I'm assuming you've run some real world tests on that machine. Can you describe, how it performs?
Yes, we put this system in this backhoe loader machine that we have, and basically we could improve and we had expert operator run the machine, and compared to a baseline machine, we could save about 15% fuel savings compared to the baseline machine. And also the operator has this adjustable hybrid power, so they could select this productivity versus fuel efficiency. The customers really like that.
Mm-hmm.
And then the other thing is when you are also in the loader test mode, when you are driving to the pile, the electric motor can assist the hydraulics during this high transmission demand. So those are some of the key findings. And then last but not least, one of the key requirements was this customer, they wanted to run this machine for about half an hour to 45 minutes with the electric only mode because of they wanted zero emissions for that.
Mm-hmm.
So we were able to achieve that as well.
That's great. So it sounds like you're working directly in tandem with a customer who's looking to commercialize this.
Yes. So, I mean, we did this tech demonstrator with the customer,
mm-hmm.
and then now we're working on phase 2 on how to commercialize this concept.
That's great. Well, those are some impressive efficiency savings. I mean, 15% is nothing to sneeze at, especially with the cost of running those machines these days.
That's true.
Yeah.
Yes.
Let's talk about the second example, if you can, because again, I think it demonstrates kind of the versatility of this approach. It's called a side loader. Is that like the garbage truck that drives through my neighborhood and picks up the waste receptacles? Is that what we're talking about?
Yes, that's what we're talking about.
Okay.
It's called an automated side loader. So it's got the arm on the side that comes, and so basically the hydraulics has two main functions. So you have the arm that comes and grabs the garbage can and then dumps it. And then there's also a compaction function on the body that's being done. And so those are really the arm function, which is a multitude of actuators, and then the body function, which is compacting the garbage so that you could put in and maintain that pressure and fill up the more garbage, so less travel, if you would, more pickup of garbage. Yeah. So what I was going to say is typically in a IC type refuse truck, what you see is the engine is typically a CNG engine, and when they come to our house to pick up, so the engine is in idle, so basically the vehicle stops. So the engine is running in idle condition, and at that time, the pump is producing all the flow to do the functions, the arm function and the body function. So basically, say the engine is at 750 RPM, the pump size needs to be between, say, 130 to 150 cc per rev, and about 40 gallons per minute kind of flow. So basically, now you have to design the hydraulic system from the pump and downstream for this big, massive pump. So, but then the issue is once the vehicle starts moving, so say the engine speed now goes up from 750 to 1500, 1800, whatnot. So now you're creating all this extra flow, which is not needed at all. So you have this 140 kilowatt of installed power when you only need is 40 kilowatt.
Okay.
So that's the other wastage here, if you would. So, and then, of course, when you're running the engine at 750 RPM, that is a very inefficient point. So you're losing your mileage is very bad, and you're creating a lot more emissions as well.
So Barun, just so I can make sure I understand what you're saying there. So what you're saying is that you said CNG, that's compressed natural gas engine, right? On the vehicle. Yes. And it if I just to paraphrase it produces the most power when you don't need to use the hydraulics. And it produces very little power when you do need to use the hydraulics. Did I hear you right? Is that the challenge? Okay.
Yes.
Right.
Yes.
And so that sounds like it's ideal for a hybrid type solution where you can store and deploy energy when capture it when you produce it and then use it later. Am I stealing your headline here, or is that where you're going?
Nope, you got it. So the idea is, imagine when it stops, just like in idle, when you are ready to pick up the garbage, what you do is you declutch the engine, and now you run the electric motor. So now I can run it at the right speed and cut down the size of the pump, create the flow that I actually need.
Right.
And then once the vehicle starts moving, that's when I clutch on, and then I can charge my batteries, the small battery, rather than having this massive battery in a garbage truck where you don't have room for collecting garbage, so you're going to have all this battery. So all you need is a tiny battery, and then the pump size cut down from say 140 cc to 65 cc per rev. So it's a huge, and that reduces the size of the fluid connectors. Everything downstream is now right sized rather than this oversized system.
So you've really built a hydraulic system that has a prime mover that is providing just the right amount of power that it needs to run, and it's getting its energy off of the engine and the battery pack when needed, right?
Absolutely.
Yeah. That sounds like an innovative design. I've not heard that described before. Is that fairly new?
Yes, it's very new, and we have tested this concept in our lab. We think you can do with about 10 kilowatt hour of battery pack. We think you can do 4 hours of refuse collection with this automated side load, because we had actual test data, because we have followed a lot of those machines around in our career. So,
right.
And then we have also designed the system so you don't create the losses, so you just create the flow that's needed because this is the EH system. So you don't create that extra flow. So the system efficiency is also the key to to make sure you're using the battery to its fullest capability.
And have you done it sounds like you've already done the tests, the studies to see, how this compares to the more traditional design in terms of energy savings?
We haven't done the energy savings piece yet. All we did is the sizing of the battery, and that's the phase we are in for this refuse truck hybrid project.
Okay.
So we're talking with customers on that. Some of the customers are using only the electric piece for the electric refuse truck, and we're talking to other customers to do the complete hybrid system. So They all agree it's a great idea.
Yeah.
But the problem is the money from the government is on a fully electric refuse truck. So we think when people start actually looking at the emissions problem, they're serious about solving that. I think this is when the hybrid solution is going to make a lot more sense.
Right. Yeah. Again, it's that trade-off between saving money and doing the work, right? So if you go all electric, you don't have the power density that you need to perform the functions.
Right.
Yeah. Well, that's exciting. So these have just been kind of two examples, Barun, I know, of a lot of the work that your group has been doing on these hybrid systems. And I mentioned at the top that, visitors to the IFPE show are going to be able to see some of this on display. Parker's going to bring some of that. Can you give us an idea of tactically what people will see, what the future of this technology is going to look like?
Sure. I'll just give a quick. So Parker has been working on both fully electric and electric hybrid solution, and the idea is to do that using standard components and controls. Of course, the controls gets a little complicated, like we discussed before.
Yep.
And we have ready-made solutions that we can give to our customers to do that. We're working on more efficient electrical machines because efficiency is the key. So, 1% savings is a huge deal from cost of battery. So you're going to see new motors, new electric motors, new inverter design with focus on functional safety that Parker is going to unveil. Some efficient e-pump solutions, which are configured to run, tested, ready-made solutions for many of these applications. And then we're also going to showcase some of the integrated systems we're working on, where the motor inverters are integrated all the way to a complete electric PTO, where we have the cooling packages, and then the hydraulics also incorporated if the customer chooses so.
Right. I know I'm reflecting back, Barun, on all of the different vehicle types that you described at the very beginning, construction and ag and utility and mining. And it sounds like these kinds of technologies would work in a lot of those spaces.
Absolutely. The hybrid system we talked about, we think it makes sense in refuse. It makes sense in many construction equipment. It also makes sense in some of the crane applications. So really, it's not one size fits all, obviously, but, it's just an innovative system architecture with simple components that could be applied in many, many places.
That's great. Well, again, we'll encourage our listeners to see all of this at the show, which will be March of 2023 in Las Vegas, Nevada. So, and I'm sure there'll be more innovations coming even after that date. This is an area that's not cooling down in terms of the marketplace and the demand for these new kind of products.
Thank you so much, Eric. Yeah, absolutely. I think, like I said, this is an amazing time, even for hydraulic systems engineers, because we always knew how to make efficient systems. It's not like we didn't know, but now because of the price point of the batteries, all those ideas that we had, make sense, and the customers are willing to use it and then tie it with this cool controls concept that we have. So this is very, very exciting.
That's great. Agreed. And that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Barun Acharya, who has been my guest on this episode. If you do want to connect with him, the best way to do that is by his email. And we're going to put a link to his email address in the show notes for this episode. I know he'd welcome anyone who wants to reach out and learn more about what they're doing and the potential applicability of these products and services. Remember to learn more about fluid power. Your best bet is to attend that IFPE trade show, the International Fluid Power Exposition, where you can see firsthand the latest fluid power technology advancements and learn from industry experts. Visit IFPE.com for more information. And remember, if you like our podcast, please remember to follow us on Twitter. We're there at the NFPA. And please keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We do want to hear from our listeners about what kind of topics you want to hear about on future episodes. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.